Hi, I'm Miel. So I'm going to talk about how we automated annotation on our audiovisual archive. Not alone, but in collaboration. So what is Meemoo? We are an organization that helps other organizations in digitization, long-term preservation, and also the dissemination of their material to targeted audiences. We also do some knowledge gathering and sharing, mostly in digital cultural heritage, but also beyond. And in that respect, we also participate with our partners in several projects. We are serving more than 180 partners at the moment that provide us with content, so we call them content partners. They're scattered around Flanders, which is the Dutch-speaking part of Belgium, and they are mostly in the cultural media and government sectors. They are very, very diverse. We have regional and national broadcasters, but we also have museums, archives, but even theater organizations that provide performances. We host a couple of web platforms that are used by different audiences to look for archive materials. This is our public-facing one, hetarchief.be. But we also have one that is targeted at teachers in classrooms where they can get access to even more content, which is curated especially for them. We do quite a lot. We have grown a lot in volume, and both in volume and services. We have about 8 million objects in our archive. We have 500,000 carriers digitized, more than 200,000 users on our most popular platform, that's the education one, which amounts to, let's say, I think 28 petabytes of data. So we have a lot of content, but unfortunately not much of that is annotated well. And this is a pity because metadata is really important to us. It enables search, it enables all our other internal processes like preservation and digitization and so on. So that's why that encouraged us to use some of these projects that we do to set up some collaborative initiatives to somehow automate the annotation of audiovisual material using AI. So I will talk about 3 things in that respect. So how we created the AI pipelines, which ones we did, how we work together with our partners to create reference sets and knowledge bases, and then in the end, how we integrate it with the existing metadata in our archive to actually use it. So first, the AI pipeline. So in a nutshell, what we do is, so we send every audio file or the audio from video file into a speech-to-text. It gives us transcripts. Then we run some entity recognition. Finally, we use a grammar filter, which I will tell you a bit more about later. And that gives us transcripts, people, organizations, and places. On the bottom, we send all the video to a face recognition system that identifies different people for us. All this metadata is gathered into a AI metadata annotation storage database, but it's also integrated in our knowledge graph, which is used to actually access the different metadata. These pipelines were applied in 2 domains, basically. So first, we used it to annotate cultural heritage content, and second, the content of regional broadcasters. We work together with 126 organizations that are part of the Meemoo network. It's their content, so we don't own any of the content. We just facilitate. And we discussed with these partners so all the legal and ethical aspects that come with this kind of project, so the GDPR requirements and all that. And they were involved with a working group, so via the working group they could steer, they could decide what the parameters were for the face recognition and so on, and what we would do and what we could not do, and these kinds of things. A little bit about the speech to text. So we used Speechmatics. We executed it on 20-60K hours of media. And of all the items that actually had audio, speech, and a language that was understandable for Speechmatics, we got a confidence per word and also transcripts in multiple languages. About 2/3 of the content was in Dutch. Then we used the named entity recognition. This was with the TextRaiser service. On all the transcripts, we tagged more than 4 million people, 2 million organizations, and 5 million locations. Where possible, we linked them to Wikidata, and it also gave us some confidence scores on these named entities. The results of those were actually pretty good. We got some high quality metadata, but it really depended on what kind of content you give it. So in the cultural heritage domain, the content is more diverse. It not always has clear audio, so the quality was, there was more variety there. In the broadcasting, it's just clearer, so the output was also better. When named entities do get a link to Wikidata, usually it means that the quality is higher, but it's also not like a magical thing, so it does make mistakes. We had this village called Welcome, but we saw it popping up in a lot of interviews in the beginning, so just to say it does have a link to Wikidata. I did briefly mention a grammar filter, so we did notice, so the first line there is actually ground truth, so we asked, I think we manually transcribed, or a company manually transcribed 150 videos. And then the second line is what actually Speechmatics outputs, but so in the middle of the segment, it switches from Dutch to French. And this is not uncommon because we have both languages in our country, so a lot of content has this. Also, like in documentaries where they show fragments, it just suddenly changes. But what we noticed is that Speechmatics was just, and this is the third line, so everything that's black, it's like very confident that it's doing a good job, but it really didn't realize that it was suddenly transcribing French as Dutch. And so what we do in the final line is check whether the grammar of the language is okay. And if not, we just take out all the named entities and all the texts, so the precision gets a bit higher. Then over to face recognition. We spent some time trying to decide whether we should build or buy. In the end, we worked together with the university to build our own solution that we could reuse in follow-up projects. On the videos of the regional broadcaster, we got about 280K annotations, which are faces and then the time codes in which they appear. We were also able to construct a reference set of about 4,000 faces that some were identified, some were not. And in the end, I mean, overall, we got some pretty detailed and high quality results. What happens after the faces are detected? So this is an example from the VRT archive and some videos from the Flemish Parliament. So we recognize the faces, and then they are matched against the reference set. So the reference set is a list of people that were identified. So mostly it's for the faces that it's able to connect to a person That's fine, but it's also faces that it does not recognize. And then it has like a clustering mechanism that just already clusters all the faces into people, but it just doesn't know who it is. So to solve this issue of identification, we turn to the archivist who has all the knowledge and is able to identify this person. And that means that once they add it to the reference set, it's also matched. And all these videos get tagged. So then a little bit more on this reference set and how this process with the archivist actually works. So first we were thinking, okay, what do we need for a face recognition reference set? It's basically a link of people that has links to Wikidata, but they also should have photos, of course. It should be managed in a shared fashion, and that really leverages the expertise that is within the sector. What's really important is that it's very transparent who adds the photo, when they add it, and that you can always see from which source a name or a person came. And in the end, I mean, the process around the reference set should somehow support ethical considerations, because in fact, if you add somebody to this reference set, it means that it will possibly be identified over like hours and hours of video, so you have to be very careful when you make this decision. So bottom line is that it's a human actually that should make this decision. At the same time, we have a lot of experience in digital cultural heritage, where you have this practice of creating a thesauri of people and publishing them. And we wanted to leverage this practice of person name authorities, of which we already have quite some published by different partners in Flanders. So this ended up in a project called Visual Name Authority, where we wanted to look at face recognition and how to create a reusable face recognition reference set. Because building such a reference set, every project is very expensive. But at the same time, when you look at the named person authorities that exist in Flanders, they're very scattered, fragmented. They don't really collaborate with each other. So you have a lot of duplicates and unstructured data. So at the same time, we wanted to look at whether we can somehow spike more collaboration between these partners and have something like a cross-authority search. So the Visual Name Authority is really about creating this resource, this thesaurus that is public and directly usable in Flanders, and that really contains specific regional knowledge that is in other sources really, really hard to find. Like, for example, small villages, the mayor of a small village, which is really not known to us, but somebody from a regional broadcaster really knows all these people. So if you can combine these strengths, it's really powerful. So it's basically, the Visual Name Authority is a list. It's a cross-organization list that contains minimal metadata about people in the Flemish context. But at the same time, it's a reference set that contains portraits of these people. And it's actually an aggregation of existing authorities and data sources. It's a partner network consisting mostly of cultural heritage institutions, and we hope soon more broadcasting companies as well. There's a very important place for multiple truths. So you will think that somebody only has one birthplace, but if you ask 5 museums, they disagree. So there's room for having multiple perspectives on the characteristics of a certain person. And what we actually do is we all give the ability for them to add their own view on this person, but then we have a consensus model that creates a layer on top and says the community thinks that this is what this person, what the death date of this person was or is. We do have already a user interface where we can manage these reference sets. So it's this tool where you can go through the different people, see what kind of portraits they have, where they were tagged in videos. You can go to a video and see what the different people were that are recognized. You can look at the details, when were they recognized in the video. And there's also the important part of identifying unknown people. So every person that we were not able to name is somehow highlighted in the tool. And then you can, or one of the partners can name this person, and it also gets feedback. So when you look at the red square, it's like it tells you how many videos you will annotate if you add this person. So it's kind of this incentive to do this work. And then one final thing, so when you can add photos, of course, of a person, which is much as prime if somebody recognized them. But there's some quality assurance, so if you try to add a photo that doesn't look like the other photos, it will tell you, are you sure that this is our minister of, I don't know, no, the mayor of Kortrijk, I don't know what it is. He changes a lot, lots of scandals. Okay, so finally, how do things come together? So 2 years ago in Dublin, I presented this thing, which is the knowledge graph. It's a way of trying to separate the applications that use a lot of metadata or need to access a lot of the archive's metadata from the actual sources that contain the data. Because we have data scattered around, we have some in our CRM, which is about organizations. We have some in our media asset management system, which is about the objects, of course. But this, and then this AI annotations database is something that is added to the mix. And the important thing about this knowledge graph is that it looks at data from a very application-independent perspective. So that means that it doesn't, it represents data not from, it has to be visualized in this user interface, or it has to be able to be edited by this form. It just tries to support as many use cases as possible. So how does that look like? The basic object structure of our archive is represented in the knowledge graph using premise OWL, which is an ontology. So we have intellectual entity, which is the metadata, which contains the metadata about the content, so a particular film, for example. Then we have different representations representing this intellectual entity. So this is the archive master, or the low-res copy, or the mezzanine copy. And these representations include one or multiple files, like in MOF or multiple WAV files and so on. So I will just quickly walk you through some examples. So this is an intellectual entity of a news item. It has links to its different items, so that's the has part. It's represented by something that was on the analog carrier, a master, and a low resolution copy is it's a video. What else is in the knowledge graph? We have also events that represent the digitization chain. For example, this is the digitization event, which was executed by Vectorcom, which is a French digitization firm. The carrier went in, the master came out, and it was done in 2017. We also have access to all the terms, concepts, thesauri that we have through the knowledge graph. So for example, this is our thesaurus of carrier types, sorry. And what else? Things that describe the context, so places, people, organizations, and all these other things. So Cardiff is in there, and a bunch of people as well. And then the nice thing about the graph is that everything is connected, so you can follow links from one thing to another. So Cardiff was the birthplace of Thomas Ellis, which was mentioned in this newspaper page, which is part of the newspaper issue. So how do these annotations come into play? So it's a graph, so what's really nice is that something can be two things at the same time. So a premise file is also a EBU Core Plus media resource. We represent it, for example, a face we represent as a media fragment, which is a part of the media resource in the time and geospatial and the spatial dimension. And then we have these annotations. So multiple media fragments can make up one annotation, which has the confidence value, which then is connected to the actual person that is recognized, and that has the link to Wikidata. And we describe our people in schema.org. Something very similar for the named entities. So we have a text annotation instead of an annotation, which contains also the start character and the end character. And then there's no fragments because there's no time dimension or a spatial dimension here. But it's now related to a location that was found, which is again linked to Wikidata. So what does that give us? So one example is if you have somebody who is looking for footage of the very early days of the biggest rock festival in Belgium, which is called Rockwerchter. So this was the beginning of the 80s, and there's not much footage that is really annotated as this is in the beginning of Rockwerchter. So you can look for intellectual entities that were created before 1980, but also mention, or that at least have a file that is the target of an annotation that mentions Herman Schuurmans, which is the person who created the festival. And then the nice thing is that this information actually comes from two different data sources. Everything about intellectual entities comes from our media asset management system, while the annotations live in the AI database. So, to conclude, so we created AI pipelines to do mass volume media annotation. What we still need to do is actually give this data back to the partners. So we're trying to create APIs and ways for them to access it. We also want to add to these pipelines all the techniques that I heard today. So please come to me. But first in line are voice recognition and summarization. About the shared reference set, so we're still in the middle of implementing the visual name authority, the minimal viable product. So we have already this tool, but we need to still extend it and make it more into a thesauri management tool. And everything that has to do with the governance, so creating the processes, the agreements with the partners, the technical architecture in with which they can let input the data we still have to create. And then finally, the knowledge graph aspects. So we did this integration now in a static way, but we still need to automate the fact that every time there are new AI annotations that they get integrated with the whole bunch. All right, that's it for me. Thanks.